For doing this question, I'll be using some concepts which should be known to you. If you don't know those concepts, still you can do the question, but it will be very difficult and lengthy to think the solution if you don't know those concepts. The first concept which should be known to you is, if you pre-multiply any general matrix by some diagonal matrix, then in the resultant matrix the elements of first row will be obtained by multiplying the elements of first row of general matrix by A. The elements of second row are obtained by multiplying the elements of second row of general matrix by B. The elements of third row of resultant matrix will be obtained by multiplying the elements of third row of general matrix by C. I know that you can easily get the resultant matrix by simple multiplication, but it is better if you know this concept directly. Similarly, if you post multiply any general matrix by some diagonal matrix, for the resultant matrix, the elements of first column will be obtained by multiplying the elements of general matrix by A. Elements of second column will be obtained by multiplying the elements of this by B, and elements of third column will be obtained by multiplying the elements of third column of given matrix by C. Previously, the same thing was going in rows. This time, the same thing is going in terms of columns. The next concept is to find the inverse of any diagonal matrix. To find the elements of inverse of diagonal matrix, simply write A inverse, B inverse, C inverse along the diagonal and all other elements 0. This is the inverse of this matrix. You must know these formulas directly. And now I'm going to tell you how to find the inverse of a triangular matrix. First, I'm dealing with the inverse of upper triangular matrix. To find the elements of resultant matrix, outside write 1 upon product of all the three elements, that is ADF. If these three are 0, in the inverse matrix also these three elements will be 0, and the elements along diagonal will be obtained by, for this position write DF, for this position write AF, for this position write AD. Hence, these three elements are easily found. To find the element here, find the cofactor of this element, which will be minus BF. Minus BF will be written here. To find the element at this position, find the cofactor of this position, that is BE minus CD. Here BE minus CD will come. And to find the element at this position, you will find the cofactor of this element, that is it will be minus AE. Hence, if these three are known to you, you have got the inverse of a triangular matrix. Presently, I have told you how to find the inverse of a upper triangular matrix. Similarly, it is very easy to find the inverse of a lower triangular matrix. And the next concept which should be known to you is Cramer's rule. in case of homogeneous equations. If three homogeneous equations are given, then if capital D is non-zero, then there will be only one solution, and that unique solution will be x equal to y equal to z equal to 0 if D is non-zero. But if D is 0, then infinite number of solutions are there. All these concepts I am going to use in the solution to this question. Here P matrix is a upper triangular matrix defined here. Q is a general matrix. R matrix is equal to PQ P inverse. Then which of the following options is oblique R correct? First option is for x equal to 0, if R matrix into this column matrix is equal to 6 times this column matrix, then the value of A plus B is 5. First of all, let us find the value of R matrix when x is 0 as it is given in the question. If x is 0, the matrix Q becomes 2 0 0 0 4 0 0 0 6, and now P Q P inverse will be 1 1 1 0 2 2 0 0 3 into Q. Q is 2 0 0 0 4 0 0 0 6. Now let me find P inverse separately. Using the concepts I told you, to find the inverse of any triangular matrix, if it is upper triangular, then these three elements will be 0. If it is upper triangular, then these three elements will be 0. In the inverse matrix also, these three elements are sure to be 0. The element at this position will be 2 into 3, that is 6. Outside 1 by 6 will come, because 1 by the product of all the three elements will be there. As I told you, in the inverse of any triangular matrix, outside 1 upon product of all the three elements comes. For this position, 6 will come. For this position, 3 will come. 1 into 3. 1 into 2, that is 2 will come. Only thing you have to calculate is element at this position, and this position. The element at this position will be a cofactor of this element, and cofactor of this element has the value -3. The element at this position will be cofactor of this position, and cofactor of this position is 0. The element at this position will be cofactor of this position, and cofactor of this position is -2. Hence you have got the value of P inverse. Hence the value of PQ P inverse. P is this, Q is this. P inverse will be 1 by 6. Using this value of P inverse, it will be 6, 3 and 2. 0, 0, 0, -3, -2 and 0. And now for multiplying three matrices, associative law says that you can multiply any two matrices first. Suppose I multiply these two matrices first. as I told you in the very beginning, if you post multiply any matrix by a diagonal matrix, all the elements in first column will be obtained by multiplying these elements by 2. All the elements in second column will be obtained by multiplying these elements by 4, and similarly for the elements of third column. Here you will be getting 2, 0, 0, 4, 8, 0, 6, 12 and 18. And 1 by 6 outside, 6 minus 3, 0, 0, 3 minus 2, 0, 0 and 2. Because these two are triangular matrices, it is very easy to find the resultant matrix. Both are upper triangular, therefore the resultant matrix will also be upper triangular. The elements at diagonal are very easy to find. It will be 2 into 6, that is 12. It will be 24. It will be 36. Only you have to find the element at these three positions. And now element at this position will be 6. Element at this position 4, 8 here. Now he is saying for x equal to 0, if R into this column matrix is equal to 6 into column matrix, then A plus B is. Then to check this choice, I put the value of R, because this was the value of PQ P inverse, that is, this is the value of R matrix. And now using R into this column matrix is equal to 6 into this column matrix, that is 1 by 6 into 12, 6, 4, 0, 24, 8, 0, 0, 36 into 1 A B is equal to 6 into 1 A B. And now take 6 on this side and compare the corresponding elements. Here you will be getting 12 plus 6A plus 4B equal to 36, 36A, 36B. Here you will be getting 24A plus 8B. And here you will be getting 36B. These two elements are already equal. I will be using only these two elements to find the value of A and B. Equating these two, I get 6 plus 3A plus 2B is equal to 18. And equating these two, I get 6A plus 2B equal to 9A. That is, I get minus 3A plus 2B is equal to 0. And now adding this and this, I get 6 plus 4B is equal to 18. That is, B is equal to 3. And if B is 3, then 3A equal to 2B implies that A equal to 2. Hence the value of A plus B becomes 2 plus 3 equal to 5. Hence A is correct choice. To check the choice B, he is saying for x equal to 1, there exists a unit vector alpha I plus beta j plus gamma k for which this is equal to this. But it will be very lengthy if we find the R matrix by using this formula for x equal to 1. Actually, I can check this without finding the value of R matrix. Agreed, it is not required to find the value of R matrix, but for understanding purpose, suppose after calculation I get the value of R matrix as A, B, C, D, E, F, G, H, I, then this will mean and this choice will become correct if we are able to find at least one non-zero value of alpha, beta and gamma, and will be able to find at least one non-zero value of alpha, beta, gamma if determinant of R is 0, that is A, that is at least one non-zero value of alpha, beta, gamma is possible only if determinant of R is 0. And from here I can easily find the value of determinant of R as determinant of P into determinant of Q into determinant of P inverse. Note that in this choice we have supposed that x is 1, and now determinant of P inverse means 1 upon determinant of P, therefore this will get cancelled, and determinant of Q, using this definition of Q matrix, becomes 2, 1, 1, 0, 4, 0, 1, 1 and 6. The value of this is clearly 4 into 12 minus 1, that is 44. This is non-zero, and because determinant of R is non-zero, using Cramer's rule I get the conclusion that the only possible value of alpha, beta, gamma satisfying this equation is alpha, beta, gamma, all the three as 0. Therefore, there exists a unit vector. This becomes wrong information. Therefore, B becomes wrong choice. And now to check the choice C, it's clear that determinant of R is equal to determinant of P into determinant of Q into determinant of P inverse. And because determinant of P inverse is 1 upon determinant of P, therefore I'll be getting only determinant of Q. That is determinant of R is equal to determinant of Q. And now finding determinant of Q is very easy. Clearly, determinant of Q will be equal to 4 into 12 minus x square, that is 48 minus 4x square. And determinant of this is also very easy to find, that is 4 into 10 minus x square, that is 40 minus 4x square, and putting this value of this here, I'll be getting 48 minus 4x square. Hence I can say C is also correct choice. And now to check the choice D, it will not be intelligent to find PQ at find QP at and then check whether the two matrices are equal or not, because two 3 by 3 matrices are equal if all the 9 elements are equal. But it will be very lengthy to find PQ matrix, to find QP matrix, and then check. What I will do, I just find the product of P and Q, but I will not be calculating all the elements. I will be calculating only one element. First, let me write the matrices. PQ equal to 1, 1, 1, 0, 2, 2, 0, 0, 3, and here I will be writing 2 x x 0 4 0 x x 6. I multiply and find the element at this position only. The element at this position will be 2 plus x. And now find QP. QP will be 2x x 0 4 0 and x x 6. Here 1 1 1 0 2 2 and 0 0 3. Here I will be getting 2. It's clear that these two can be equal only if 2 plus x is equal to 2, that is x equal to 0. That is, these two matrices can be equal only if x is 0. Now it becomes very easy. We have already found the value of PQP inverse for x equal to 0. In the first choice I had calculated. Recall that this was the value of PQP inverse for x equal to 0. As we have found that these two can be equal only when x is 0, and equality of these two means PQ P inverse is equal to Q. I have multiplied by P inverse on this side, and we already know the value of PQP inverse. This is the value of PQP inverse, and now I put the value of PQP inverse in PQP inverse equal to Q, and this is equal to, that is 2 0 0 0 4 0 0 0 6. Clearly they are not equal. Again, let me tell you that the only possibility when these two could be equal was x equal to 0, and we have found that for x equal to 0 they are not equal. They are not equal means these two are not equal. Hence there is no value of x for which PQ is equal to QP. Hence D choice is wrong.